In this video we are going to look at some functional group tests for organic functional groups. The first functional group test we're going to look at is the test for a carboxylic acid. To test for a carboxylic acid you use either sodium carbonate or sodium hydrogen carbonate solution. These solutions react with acids to form a salt, water and carbon dioxide. And it is the production of carbon dioxide that gives us the positive result in this test. Carbon dioxide is a gas, and so if there is a carboxylic acid present, we should see some effervescence. For this test we've decided to test oxalic acid. Oxalic acid contains a carboxylic acid group. If the test works, we should see the fizzing, the effervescence due to the evolution of carbon dioxide gas. There we go, we've got effervescence, fizzing in the test tube. Oxalic acid must contain a carboxylic acid group. Just to prove that this doesn't happen with everything, and this is a test for a carboxylic acid group, I'm going to show you the reaction of sodium carbonate solution with an organic compound that does not contain a carboxylic acid group. So we've chosen cyclohexane. Cyclohexane has no carboxylic acid groups, and so should not effervesce with sodium carbonate. There we go, you can see now there's no observable reaction, no observable change in that test tube. There is no carboxylic acid group. Test 2 is our test for an alkene, and to test for an alkene you might remember from GCSE that you use bromine water. Bromine water is a yellowy orange solution, and when it reacts with alkenes it undergoes an addition reaction, and the bromine water is added to the alkene, and so the colour of the bromine water will disappear, often referred to as decolorizing the bromine water. So into our test tube goes our bromine water, and because there's a small amount there it's hard to see the colour. So if we just have a look against a piece of white paper, we can see that it is a pale yellowy orange colour. That's our bromine water. So what the substance that we're going to test today is called maleic acid. Maleic acid contains a C double bond C. What we're going to do is we're going to place a small amount of maleic acid into the test tube with the bromine water. There we go. And give it a little shake. We can see that the orange colour has disappeared. It's very difficult to see, but there is nothing in that test tube of any colour. The white bits are just unreacted bits of maleic acid. Again, to prove for the negative test, we're going to add some bromine water. We're going to again use the cyclohexane, which is a saturated 6-membered ring, has no double bonds. I'm just going to give that a little shake, and if you hold that against the paper you can see that it has remained orange. Test for an alkene. And now we're going to test for an aldehyde. There are two different tests for an aldehyde. This one is testing with failing solution. And to make failing solution you need to mix the two parts. It's a two-part solution, so we've got failings 1 and failings 2. Just going to mix together. Failing solution contains copper 2+ ions. That gives it the blue colour, characteristic of compounds with copper 2. And copper 2 ions in failing solution will react with aldehydes, because aldehydes can be oxidized to carboxylic acids, and therefore the copper 2 ions in failing solution will be reduced. They're reduced to copper 1 oxide. Copper 1 oxide is a brick red precipitate, so if you have an aldehyde present and you're using failing solution, you should see a brick red precipitate. So we're just mixing Fehling's 1 with Fehling's 2 here. Fehling's 2 contains some sodium hydroxide. So mix these two together to make Fehling's solution. So there's our blue solution of Fehling's. Small amount of that. We're going to use this on 2 separate tests, one with an aldehyde functional group in, one without, so that you can see the difference. So just going to separate that so it's equal quantities. And we're going to use the linear form of glucose. The linear form of glucose has an aldehyde group at the end. So we're just going to add a little bit of the glucose into the Fehling solution there. And in our, we're going to add it to some hot water, because for the oxidation of an aldehyde you do need to warm your solution. And then in our second Fehling solution we're going to add some cyclohexane. So I've got some cyclohexane to go into our second batch of Fehlings. On the left we've got Fehlings with our aldehyde, and on the right we've got Fehlings with our cyclohexane. You can see that in the test tube on the left there is definitely a reaction occurring, and now you can see that eventually over time that there's definite formation of a brick red precipitate in the test tube on the left, and in the test tube on the right nothing has happened, no observable change. So the glucose contained an aldehyde group, but the cyclohexane did not. And then finally we've got the test for primary and secondary alcohols. And we're going to use acidified potassium dichromate, because primary and secondary alcohols can be oxidized when warmed with acidified potassium dichromate. So just adding a small amount of acidified potassium dichromate to each of these two test tubes. So it's a powerful oxidizing agent. When it reacts with a primary or secondary alcohol, they will be oxidized. It will also oxidize an aldehyde. And as it does its reaction, it is reduced to chromium 3. Chromium 3 is green in colour, and so the colour will change. So what we've got here is tartaric acid. Tartaric acid contains a secondary alcohol group. A small amount of tartaric acid in with the acidified potassium dichromate. And again we're going to use cyclohexane, which is a cyclic alkane and doesn't have these functional groups for the negative test. So we've got two things there, one with our tartaric acid, the secondary alcohol, and one without. And again we're putting them in a hot water bath to warm chemicals. And we can see that in the secondary alcohol group oxidation occurred.